Welcome to Friday, Honors Math 1. This is Mr. Roberts, and today we're going to be looking at a relatively new topic for us, and I'm going to be tying it back into something that we've done for a while. So we're going to be discussing how do you simplify radical expressions. So you'll look at that mostly in the last 2 pages, but actually you'll see this here, and we'll discuss it as I set up some of these first examples. So what's going to happen on this page is there's 2 examples, and you're responsible for copying down and doing these examples exactly. So we'll have example 1, and over here example 2. And for each of these, what I'm going to ask you to do is to find the perimeter of the polygon that I give you and its area. So the first one, I'm going to give you vertices. So the vertices of this polygon are at 3, 5, at 3, -7, and at -3, -7. So copy those down. And we're going to carefully plot each one of those points. So for the first one, x is 3, and then over 3, and then I'm going to go up to 5. So here's my first point at 3, 5. The next point I have is over 3 and then down to -7. So 3, -7. And then the final point that I have there is -3 and also -7. So now I'm going to go back to -3 on x and then down to -7 also. So those are just the 3 vertices, and it is a triangle, right? And it turns out it's a right triangle, which is convenient. So I'm going to go ahead and sketch it by just connecting these vertices. And again, I'm asking us to find the perimeter and the area of this triangle. So I guess probably the easiest thing to deal with first is the area of this triangle. I know the dimensions along the bottom. This is 1, 2, 3, 4, 5, 6 units long. And I can get that by taking, for example, the 3, the x value here, and subtracting -3. So 3 minus 3 is 6. That's 6 units long. And I can do the same thing for this other side. By the way, these are vertical and horizontal lines, so they do form a right triangle, which is going to be convenient in finding the perimeter and the area, actually, for that matter. So the height of this triangle is 5 minus -7. So if I was going to write this down, this is exactly 12 units long. So in order to find the area of this, I could consider this entire rectangle. And this rectangle has dimensions 12 by 6. However, I don't have the entire rectangle, I just have the lower half of it. So that's why the area of this triangle is, of course, of any triangle, is 1/2 times the base times the height. So I can just say 1/2 of 6 times 12. Let's take half of that. And if I want to simplify that, I guess I could go, I could divide either one of these. These are not terms, they're factors. So I can create a giant one and divide 6 by 2 and get 3. And then 3 times 12 would be 36 is the area. And these are 36 units squared. Or I could go 12 divided by 2, that's 6. And then 6 times 6 is still 36. So I get the same thing either way. It's kind of a nice thing to think about, right? Why can I simplify that like that? Because there's giant ones there, and it might be helpful to think about that. In fact, I want you guys to copy this down, right? This is 6 times 6 times 2, because I just rewrote the 12 as 6 times 2, and then in my denominator I have a 2. So you can see that there is this 2 over 2, that common factor, and it forms the giant 1, 2 over 2. So I'm left with an area of 36 units. So I'm going to box this, and I'm going to label it the area. And the other thing we need to know is the perimeter of this. Now, to find the perimeter, I'm going to need to apply the Pythagorean theorem. And I know in the Pythagorean theorem, right, I have a leg squared times a leg squared is the hypotenuse squared. And these legs, the legs always, of course, emanate from a right angle. So you can see I've got a leg that's 6 units long and another leg that is 12 units long. So I'm looking at 6 squared plus 12 squared, or 36 plus 144. And if I add those up, I get 180. So the of course, the other side, I could label it C. It's kind of arbitrary what I call it. I'm going to call it C. So the length of this, the hypotenuse squared, right? The hypotenuse squared is equal to 180. So I can write that over here. This hypotenuse squared is 180. And if I take the square root of both sides, there's two things that I can square to get 180, both the positive and then positive root 180 and the opposite of root 180. I'm just going to go ahead and look at the positive one, so because it's the length of a side of a triangle. So I get about 13.4. So I might write C is approximately 13.4. So if you were going to write the perimeter of this, it would be 12 plus 6 plus 13.4. So I could add those up, 12 plus 6 plus 13.4. So we're getting a perimeter here of approximately, and this is an approximation because C is actually the square root of 180. We're going to talk about more about that on the second two pages, but for now, I want you to write it down as it's approximately 13.4. So the perimeter is approximately 31.4 units. Okay, so one of those is how long it would take for me to walk all the way around around this triangle, and the other one's the area. So that's the first example. The second example is pretty similar. On it, we're going to go ahead and list this as I want you to consider these points. So I'm going to give you -5 and 5, and I'm going to give you -1 and 5, and then the last point will be -5 and 1. So same thing, I'm just going to very carefully plot those. So I've got -5 and then up to 5. I've got -1 and up to 5. And then I've got the point where I'm going to go -5 and just up to 1. So this is my triangle. Two of these sides are the same length, right? I think two of these sides are 4 units long. 1, 2, 3, 4. So this is 4, and this is 4. So again, I have a right triangle, and the area of this it's half the area of this square, right? So this square would be 4 times 4, 16. So this is just 4 times 4, which is 16 over 2. And 16 divided by 2 is 8. So my area is 8 units squared. And the perimeter of this, I know part of my perimeter is the 4 plus 4, right? One side is 4, and this other side is 4. But again, this side right here is a hypotenuse of a right triangle, and I need to find that length. So I'm going to go ahead and do the Pythagorean theorem again. And I'm just going to go ahead and write this time the hypotenuse squared is equal to the leg squared plus the other leg squared. So c squared equals 16 plus 16. C squared is the number 32. And again, I want you to write this as a decimal approximation until we get to the last two pages. So this is going to be the square root of 32, which is about 5.7 if I'm rounding to the nearest tenth. So my perimeter, so I wanted to, the square root of 32 is approximately 5.7. So the perimeter is equal to 4 plus 4, which is 8 plus 5.7. So 8 plus 5.7, which is 13.7. And these are just units, they're not square units. Okay, so we've got, and I might write this as 4 plus 5.7, just in case the reader's wondering where that came from. So 13.7 units is our perimeter. Okay, so the two that I want you to do on your own or independently, or you can consult and work with your groups, of course. And I'm just going to list the coordinates here. So the coordinates are at -7, 2 and -7, 8, and the other one is at 1, 8. So go ahead and do that here. Again, what's the perimeter? What's the area of that polygon? And then one more, which is a little bit more complex, and I hope you do work together on this. -6, 1, -6, 5, -3, 9, -1, 9, and I'm not done. 3, 6, and 3, 1. So -6, +1, -6, 5, -3, 9, -1, 9, 3, 6, and 3, 1. So this is not a triangle, right? This is a polygon. I think it's what, 1, 2, 3, 4, 5, 6. It's a hexagon. It has 6 sides. It's not a regular hexagon, but do look at it. What is the perimeter of that regular hexagon, and what is the area of that regular hexagon?